Hello Professor, my name is Zhichao Sun and this video is to explain the question 2 of homework 5. And for the first question, it told us to draw the non-zero definition region of the joint probability function of xy, and from this question it told us the value region of the definition region of y and the definition region of x. So we draw this picture, and this is two functions of to limit the value of x. This is y equals to x, and this is y equals to 1 divided by x. So we found that the joint point, this point is 1 1. Yeah, when y it told us y larger than 1, so it is the upper bound, and y larger x larger than 1 divided y, so it is the right region, and y x less than y is the left region. So this one is the joint region, and this is the definition region of the joint probability function fxy. Second question, find A so that fxy is a valid joint density function. When it is a joint valid density function, is that is integral formula of this one equals to 1. So we use the formula and let this in here, and we calculate this, and then we got that 2 divided by a equals to 1, and we solved a equals to 2. For the second question, it told us find and draw the marginal density function fx and fy. So from the PowerPoint, we know that the marginal density function fx and fy is equals to fx equals to this and equal to this. So we just solve x first. We found the definition region. It's obvious that this picture is divided to two parts, and it has different function. And when x larger than 0 and less than 1, and fxy equals to 1 divided 2, and when x larger than 1, and then we got that the lower bound is x, so it is the 1 divided x. So we get that this answer. And to solve the question, solve fyy. Fyy, from this picture we could get the upper bound of x is y, the lower bound of x is 1 divided y. So we use integral formula to get that is equals to ln y divided the power of y. And we don't ignore the definition region of y. It told us in the question that y larger than 1. So we write it down. And when y less than 1, it's no joint region of x and y. So the fy equals to 0, and the picture is like this. The fourth question is that it led us to verify fx and fy are valid density function. We just use the integral formula to calculate the fx and fy. The cumulative probability function of fx and fy. So we could get this is equals to 1, so it's valid. And from here, this is equals to 1, 2 is also valid.